that sort of stuff. It's a lot more scalable because you can buy 2 Centrex lines or you can buy 10,000 of them. If you've got a PBX, sometimes you have to do a forklift change, which means go into the phone room and pick up your switch with a forklift, dump it off the end of the loading dock and put a new one in order to get more connections or different capabilities. The phone company does all of that sort of stuff. Also, they've got switches all over the place, so you can certainly come up with schemes where you have 4 and 5 digit dialing between all of the cubicles in your entire organization, even though it's spread out across the state or across the country. The negative aspect of Centrex is that it's more expensive than having a PBX. One of the ways that it's more expensive is moves and changes. Because when you have Centrex service, usually you're not allowed to make changes to the wiring or to the switch. And so anytime anybody ever changes cubicles, you have to phone up the phone company and they'll send a unionized technician in a nice brand new shiny truck to come and do that for you. That costs $80, $100. And how often do people move in your organization? Well, once a year. So right there we've got $100 a year per line charge for moves and changes. Other ways that Centrex is more expensive is that you pay per line instead of per trunk. Remember, with the PBX you're buying trunks to connect between your telephone switch and the central office switch, and it's about a 10-to-1 ratio between lines and trunks. So even though PBX trunks are more expensive, you're not paying for 200 of them, you're only paying for 20 of them. With Centrex, you have to pay for all 200 connections. Also, features. We start thinking about all of the value-added features that phone companies are using to generate cash these days, like caller ID, for example. You have to pay for those when you've got Centrex. If you're doing it on your own telephone switch, that's part of the software load, so you don't have to pay per line for all of these features. It often comes down to a question of what business are you in when you're deciding whether to get PBX or Centrex. And if you're a small .com startup company, well, you're going to pay the phone company to do this. You don't have energy to spend going into the phone business, knowing that they make a profit. Centrex is part of the bread and butter at the phone company. You're happy to pay them and let them make a profit because you'd rather concentrate on other things. If you're a large organization like Boeing or an insurance company or bank, and you do have enough energy to go into the local phone business, then you can save money by doing it yourself. Okay, so that's traditional telephony. Now let's look at implementing voice over IP. And since we were just talking about Centrex, let's talk about Centrex voice over IP. The idea here, if you take a look at the diagram, is that on the right side, the customer has IP telephones and servers and desktops all plugged together using a LAN onto a router. And then from their router, which is the, I really don't like this word, gateway between the in-building system and the outside world, we've got an access circuit going to the phone company. And the phone company is providing gatekeeper services as a network service. The phone company provides gateway services and connections to lots of other networks. Some of the networks that the phone company is going to connect us to, the public switch telephone network, so you can phone home, and it's also going to connect us to managed IP services. They would be happy to do that. They're going to connect us to the internet, and in the future, they're going to connect us to a voice over IP carrier. The reason why we call this Centrex voice over IP is essentially the only thing that you have to deploy are the IP phones and a LAN. And the phone company will probably sell you or tell you which IP phones to get, and they'll take care of doing everything else. They do all the setup, they do all of the gatekeeper services, they do network connectivity, maintenance contracts, they do it all. But just like Centrex is part of the bread and butter at the phone company today, Centrex Voice over IP is going to be part of the bread and butter going forward. With this story, we start getting closer to part of the holy grail in the telecommunications business. The holy grail is having one access circuit, one service, and one bill for doing both voice and data communications. So in this scenario, the access circuit, if it's hardwired to the local exchange carrier from your building, and it could be a fiber or theoretically a T1, although that's sounding kind of slow these days, then you have a pipe that moves lots of bits per second, and we can move IP packets that have both voice and data in them, and the data could be going to different types of IP networks. The voice could be going over voice over IP networks or get converted to go over regular telephony networks. An interesting point here is the little asterisk beside the label access circuit on the diagram. Because if you think about it, that access circuit to connect the carrier to your building, all it has to do is move IP packets from A to B within a certain delay and with a certain quality. And the easiest way to do that would be to have a fiber going from your building to the local exchange carrier. But if we drew a little cloud in the middle there and said that that access circuit is running across a network where there is a guarantee as to delay, and the delay meets our end-to-end delay budget for doing voice over IP, the implication of that is that the service provider of this Centrex service could be anywhere. They could be located in Maine or Oklahoma or Saskatchewan, and they could be providing voice over IP service to businesses in New York City. Because as long as you can move IP packets from your place to their place and vice versa within a certain delay, that's all we need to do to provide these services. This is going to be an interesting area because the implication is that all of the carriers can start going into business in their competitors' backyards. What's missing from this picture? A firewall. If we're going to connect your in-building communication system to the internet, we must have a firewall in between the two of them. And a firewall is a box that sits in between you and the bad guys. And this box, for a data firewall, brings in an entire message, which could be in hundreds of packets, and reassembles the message and uses application software to look at that and see what it is. Maybe scan it with a virus checker. If it doesn't like it, it throws the thing away. If it does like it, it resegments it and puts it in new packets and relays them onto the safe side of the network. For voice over IP, we're going to have slightly more sophisticated techniques where we're going to have to detect streams of packets coming in, and after we've detected the stream and identified that as being a phone call, then we'll let all of them through without having to bring in the whole phone call in IP packets and reassemble it like a voicemail message and transmit it on its way. Here's the do-it-yourself plan, which at the beginning of voice over IP deployment certainly is more popular than Centrex voice over IP. If we take a look at this diagram, we see that we've got the same story. We've got IP phones, we've got desktops, we've got servers, all connected together with a LAN to a router inside the building. But the difference is that also inside the building we've got a server running a gatekeeper function. We have a firewall and a gateway to connect directly to other networks. We're not going through a carrier to get to them. The gateway is going to translate between the voice over IP standards inside the building and public switch telephone network standards for calling, well, pretty much everywhere else at the beginning of this story. If we want to connect to another location of our organization that has voice over IP in building, then we're going to go through the firewall and onto an IP network to try to do native IP from one qubit